I think we're good. All right. My name is Kamla, and I'm a project manager at Mphasis. I have been with the FRB account for 3 years now. I'm currently a QA manager with the Core Transformation Program, and I'm part of a 4-member team that provides governance, guidance, and oversight in the entire QA phase of the transformation program. So we at Mphasis are very excited to have you here today at the Tools booth in the exhibition hall of the enCore Virtual Tech Fair at First Republic Bank. As the saying goes, the best investment is in tools of one's own trade. Tools can accelerate the core banking transformation and help businesses perform better. So with that in mind, for this afternoon's presentations, we have picked 2 very interesting solution accelerators that Mphasis has developed. We hope you find this valuable. The first demo will be Topograph, which is the industry's first platform-agnostic, data-driven automated tool that uses data as a means of assessing overall enterprise DevOps landscape. And this demo will start shortly after this introduction. The second demo today will be Knowledge Graph. Knowledge graphs provide a real-world representation of the company's business logic and an integrated view of its different domain knowledge. Using a knowledge graph to represent data provides comprehensive views of the vast sets of data and links these views to real-life connections. The knowledge graphs demo will start at 3:45 p.m. And depending on the Q&A session after this first session, we will have a 5 to 10 minute break between the 2 demos. Please remain muted while the session is in progress. You can post your questions in a chat window. We have Saransh monitoring the chat window, and we will take up those questions once the first presentation and demo is completed. So with no further delay, I'll hand it over to my colleague, Richard Wolf, who will take us through the first presentation on Topograph. So on to you, Richard. I'm going to stop sharing.
Yeah. Thank you for that introduction. Appreciate it. I'll just get a couple things set up here. Yeah, so a little background on myself. I am the head of product at Mphasis Intelligence. I've got about 15 years of development experience. Had a lot of different roles building products, principal engineer most recently before this role. So a lot of DevOps experience. A little bit about Mphasis Intelligence. We as a company have been around for 15 years, AWS Premier Partner, very active in the community. We say that we want to automate everything. Okay. So in our experience, really the challenge that we see over and over again is companies struggling to implement DevOps properly. We've all heard the buzzword DevOps for years, and it's been positioned as this kind of magical implementation that's going to solve all of our problems. Now, this is a top 10 financial enterprise that we talked to, and they're actually on their 3rd DevOps Agile transformation attempt. They had spent $1 billion trying to move into this new form of operation, and it's a very extremely complex roadmap. So the companies we talk to, they have thousands of apps, thousands of teams, hundreds of different tools. It's fairly difficult to navigate. We notice that there's a struggle between business and IT, and oftentimes there's even a struggle between IT and IT in terms of understanding the data. We've got siloed data and proxy metrics. So where am I going with all of this? So you're going into this DevOps transformation, and in this scenario, imagine that's a piñata. Okay, so you're at this party. I know in these COVID times, that sounds pretty appealing. You're at this party, there's a piñata inside, there's all of the benefits of putting in DevOps correctly. So the question you have to ask yourself is do you want to go in with the blindfold on or the blindfold off? Do you want to go and take it and swing that bat once and get through this process? Or do you want to have the fun of swinging multiple times? So for those of you that aren't familiar, a lot of this is rooted in DORA. DORA and Google put out a yearly report called Accelerate which is the industry DevOps report on various metrics, KPIs, as well as benchmarking. So this was one of the starting points and anchors for how we started to develop this tool, was looking at the most important metrics for businesses in DevOps. So a couple that we have here are the four most important. They also added availability this year. Deployment frequency is how often your teams are actually deploying code to production. So as an example here, we see a lot of companies that are still in a waterfall type of environment where they're deploying code every 1 to 6 months. Normally these companies have a heavyweight change management process, a lot of red tape. They have tightly coupled team structures, meaning that one team is dependent on another team or multiple teams in order to release that software. Whereas on the other side of the extreme, we have the elite performers. The elite performers are deploying code on demand. That means multiple times per day. Ultimately, this means very small, granular chunks of code, rapid iteration, lots of unit testing, integration testing, great pipelines that allow them to achieve this. The next one we have is the lead time for changes. This is how long it takes from the code to be checked in or committed to actually running in production. Oftentimes in less automated environments, it can take days, if not weeks. The pipeline fails, there's a little issue they detect down the line, right? Whereas, and of course, the elite companies, they're doing this in less than a day. The next one is the restore service time, also known as the mean time to recovery. This is when there's an incident, how long does it take you to get that application back up and running? Studies have shown that a minute of downtime can cost anywhere from $10,000 up to hundreds of thousands of dollars for the size of the enterprise and applications. So this is an interesting one as well. The last one here is the change failure rate. So that's how often does the pipeline actually fail when you're trying to roll out those new changes. It could also be a degraded service as well. So it could just simply be a button that isn't clicking or something's out of place. For the failures, obviously every time it fails, there's a loss of productivity, and anytime that there's a little degraded service, there's some changes. So all of these are critical to how your operation is performing from a DevOps perspective. And what we've done is we've built a tool that doesn't just look at these, but it looks at some of the KPIs from all across your organization in order to help you both understand the needles you're pushing, the investments, and the rewards that you're getting from it. So we say Topograph, helping enterprises achieve the DevOps promise. This is a very high level view of how it works, but essentially the idea is how can we understand productivity and value stream management? How can we identify the tool chains, the bottlenecks in those tool chains, and also benchmark things like Agile and Dora and the velocity coming from Git itself. Once we're in there and we've collected this data from the CI/CD, the version control, Agile, and the cloud systems, we then have a bunch of algorithms where we calculate some velocity, maturity, security, code quality, as well as value delivered, which value is a little bit of an abstract word. It's got a lot of different meanings. We like to think of this as your single source of truth for DevOps, and that this is all done with some fairly advanced algorithms that we've cooked up here. So before we go into the demo, I'm going to kind of walk through the high-level design, just stepping you into it one step at a time. This is what the solution looks like from a very high level. So at the top there, you can see we've got a bunch of different crawlers. We integrate to AWS and GCP, where we pull some tags and some environmental data. We hook up to agile systems such as Jira. From here, we look at all of the user stories, the issues, the open closes, the changes. From the CI/CD systems themselves, such as Jenkins, Travis CI, Azure DevOps, we pull all of the build data, right? And I'm sure you've seen solutions before, like Elk Stack or Splunk. Those actually take the logs. Whereas what we're doing is we are taking all of the historical data from the APIs. So we can put this in place and immediately see back tens of years, however long those systems have been in place. So from the pipelines, we take the builds, the fails, we take the runtimes. In order to calculate Dora, you have to look for kind of these interesting sequences of between the last pass and the last fail and the last fail and the last pass. Oftentimes those aren't sequential. And the last one where it gets kind of interesting is the Git crawler itself. So we actually go into the repos, we detect the key events, which is PRs or tags or someone pushing directly to master and main. From there, we've got a couple of different ways we process the data. We look at all of the commits for the users, and we go into not just the number of commits, but we look at the diffs. So in a commit is the diff, and in that diff is patches. And those patches are individual lines of code that have been changed. And what we do is we go through, and there's 8 different categories for these different types of diffs. We go through and essentially we evaluate, is this a feature, is this a det, or is this a defect? We also have some logic to determine if they have modified things like comments and configuration. So that's how we come to the velocity KPI that we're looking at. Over for the DevOps maturity and quality, after talking with a lot of clients, we found everyone has some sort of homegrown application compliance tool. They're looking for various strings in the declarative pipeline files. They're looking to see if SonarQube is hooked up properly or other linters and unit testing is implemented correctly. So what we actually do is we go through the files, the key files there that we detect, and we tokenize them. We also have some custom regex for application compliance. And essentially we can determine the tool chain that's being applied, as well as the maturity from a DevOps perspective for the repo. Now, moving on over to the development value there. If you look at GitHub, they have a fairly simplistic way of looking at the number of lines of code that have changed. And our thought process was, well, there's new files people copy and paste in, there's auto-generated files. There's a lot of different programming languages out there. So our thought process was, what if we can kind of better slice and dice this pie in order to have a better understanding of how much value and development and velocity is actually occurring. So what we do is we look at both the number of lines, the characters, the comments. We filter out a lot of things. We look at the file type to understand the value that's being delivered. And essentially through just looking at quantity and quality, a couple layers deeper, we're able to get more detailed calculations on the development value that's occurring. And then the last one we're going to talk about before we hop into the demo is the risk KPIs. So I'm sure a lot of you are familiar with SonarQube. SonarQube, you put a trigger in your pipeline and it pushes an artifact. It's a very time-consuming process to put some of these static analysis tools into all of your different repos. What we can do is we can actually go pull the code, and we can run both the application linters as well as linters on all of the DevOps files across the entire organization. And of course, we're looking at the lines where those errors were detected, and we correlate that all back to the modifications that are being made by the users. So it's a fairly complex. What this actually looks like is it's a cluster of microservices. There's about 30 different Docker containers to get all of this done. When we turn it all up and running, it can process a few hundred repos an hour, which ends up being hundreds of thousands of commits, tens of thousands of PRs, potentially millions of files. So it's a pretty beefy infrastructure there. Let me just hop over to the demo now. Okay. So, log in here. All right. Minimize this guy. Okay. So to give you a base understanding of how this works, essentially we've got 2 types of data, groups and sets. A group could be a business unit, or it could be a team that's comprised of multiple applications. And then a set allows us to take multiple groups and look at all of that data put together. So ultimately, we've got 2 types of screens here. Screens where we're looking at the data from across all of the sets, and data where we're comparing the groups against each other. The first one I'm going to show you is the scorecard. The idea behind this is that we have a lot of C-levels that told us they very quickly wanted to understand where they were from a benchmarking standpoint. Before I get too far into this, I want you all to know as well that this is data that we pulled from Google, GitHub, HashiCorp, and Microsoft, right? So they've got some open source repos that we could take a look at there. So going in, the thought process for development efficiency is, if I came in here, I might see that I've got a fairly good rating for the amount of defects that are occurring, but I've got a very low rating for the debt percentage. So all of these percentages are not the percentage that's occurring, but it's actually a score rating going from low, medium, high to elite. So if I was a decision maker, I came in here, I saw our debt percentage was, we've got a really bad debt rating. We probably want to start thinking about how we're running our agile. We're going to want to investigate which teams are leading to this. Maybe there's specific developers that we could even drill into. Going down to the next one here, we've got the CI/CD quality. So, and this is from across the entire organization. So here we'd say, okay, our static analysis is pretty high. We've got most of our triggers in place. Our testing could probably be a little bit better. We might want to think about doing some unit testing, integration testing, smoke testing. And if we just keep on scrolling down, the deployment rating is a little bit more core to some of those DORA metrics I was talking about earlier. We can see the lead time is fantastic, the runtime is pretty good of the pipelines themselves, and that the recovery could probably be a little bit better. So we might want to consider putting some monitoring and alerts in place to help us more responsively react to those incidents. Now this is just the most recent period. So at the top here, you can see that we do have our set, and then we have the period. This is over the last year. If we go to the value streams, now we can actually see this same data in buckets over the course of the last 4 years. The idea behind this screen is how can we put together the most 20 important KPIs to understand our investment, which is DevOps maturity, to how things like our DORA metrics are being affected. It also lets us see the development value that's occurring and the correlations between some of our core development metrics over here. So just to run you through a couple of use cases, we can see that there's been a steady increase in pipeline across these organizations. We can see that there's been more of an investment in automation. And ultimately what we're seeing over here is the reduction in failures from the year before, right? So we can see that this investment has actually paid off significantly, the amount of failures that we've reduced, as well as the failure frequency. Now going up here to the top, we have the development value. Yeah, going up here to the top, we've got the development value. Something that's interesting is you'll see the green is the debts and the red is the feature. And this is coming from the FANG companies. So what we found through going through all of this data is that the big companies like Facebook, Google, Amazon, by the time they actually get their code to production, they have created 50% tech debt, which means they've rewritten the entire thing once, which is was kind of wild to think about at first, but then we started looking at some other companies, and it's not uncommon. A lot of companies are rewriting the entire code base 2 or 3 times by the time it gets to production. So that's kind of interesting. And then you can, of course, correlate these to some things like the PR duration, the PR size, the commit frequency, to better understand what's impacting that. Okay, so next we've got the dashboard. The dashboard is simply for today. So most of these screens we're looking at years, but everyone wants a dashboard. So we decided that we'd add one. Essentially the dashboard's got some of the key events for the day. We track the day over day shift in the quality score, as well as just the base velocity that we're seeing. And we also look at the number of failures and recoveries that are occurring. At the top here, we've just got a couple of more graphs based on the DORA for the day, as well as some of the development stats for the day. Now moving down to productivity, this one is pretty interesting. So we talked with a lot of clients like, I won't mention any names, but we talked with a lot of clients who are spending hundreds of millions of dollars on vendor contracts. This client in particular had 3 vendors they spent $100 million on, and they didn't really know how much value they were getting for this massive investment. And whether it's a vendor or whether it's your internal teams, we all know that development costs a lot of money and that there's not a lot of great ways out there to really identify how much work is getting done. I like to talk about Agile being a purely qualitative process. Okay. So essentially, it's someone who decides that they feel that this much work is worth this many points. Now, if we talk to Joe on the other side of the organization, he might have very different feelings about productivity. So our goal here was, how do we actually start to be able to measure apples and bananas? How do we say, hey, we've got team A over here that says this is worth 1 user story point. We've got team B over here that says this is worth 1 user story point. They're both programming with different languages and frameworks. How do we go about actually measuring these two? So we start off by calculating the cost per user story point, which is fairly straightforward. We just gotta figure out the spend divided by the user story points. The really interesting one is user story point coefficient. So what we do is we take all that get data that I talked about, and we look at the quantity, the quality, the velocity, right? We look at the debt percentage, we look at the issue delta, and ultimately we calculate, which is a much better estimate for the user story point coefficient. And if we click around here on the top a little bit, we can see the user story point coefficients across our different teams. All right. Now we take all of this information and we put it into both a period rating and a team rating. The team is averaged out over the last year, whereas the period rating is just for the last month. And the idea here is that we want to track this as an investment. So if you have a lot of stocks in your portfolio, I'm sure you're interested how those stocks are doing on a monthly basis. And if you've got a lot of developers in your business, you're probably interested in how much work and value is being delivered from those developers. Of course, we've got a couple of charts down here from where the data is being pulled from, so you can look at it over time. And then we also have a table view where you can jump into the individual repos or teams that all of this data is being pulled from.
Hey, Richard, just a quick time check. We probably have another 5 minutes for you, and then we can take some questions.
Okay, I will. I'll roll through these last 3 slides very quickly, and then I'll kind of recap on a couple of things, and then we'll do some questions. Sounds great. Okay, so this is the metric slide where we start to actually compare the different teams against each other. I'll jump right into some of the more interesting ones, such as velocity here. So we can actually look at the amount of comments in the code from different teams. If you're a coder, if you've ever been a coder, you understand how important comments are. We can look at the PR commit count, which is critical to all of our door metrics, right? How many actual commits are being placed per PR, the commit frequency. And there's an interesting story that's actually being told on this screen. That's HashiCorp. HashiCorp doesn't have a lot of commenting. Let's see up here, HashiCorp has some very large PR sizes, and that out of all of the teams on here, that it looks like actually GitHub is probably the best performer. We've got some line views where you can take a look at all of this data. And then finally, we actually have the core door metrics on this screen down here. So you can see we've got the lead time, the deployment frequency, the mean time to recover, the failure frequency that we had on the first slide, and then it automatically calculates the low, medium, high, and a lead performer. So just to recap on that, the percentages correlate to your score between low and a lead. All right. We'll jump back over to the demo or to the slides here. I'll just get this going again. Okay. So data is great, but obviously you need something to do with it to impact the bottom line, right? So our core goals here are reducing tech debt. We're reducing tech debt at multiple levels. We're looking at how the developers operate. We're looking at that agile data. And we're even looking at the change management processes. So how to eliminate tech debt in multiple layers of the organization. Some of the core planning aspects are backlog health, remediation, the user story exchange and inflation, and that user story coefficient that I was telling you about. For development, we like to talk about minimizing developer downtime through the rate at which they can work. So better tool chain, faster pipelines means that they are engaged with the work the entire time and they don't have to detach. In terms of the tool empowerment, what we can do is we actually look at the tools and we correlate those to the DORA and to some of the Git velocity metrics, identify different bottlenecks, as well as come up with actionable insights on how to help your lowest performing teams start to act like your highest performing teams, right? And obviously the core here is we're just trying to accelerate the speed at which the organization operates. So just one last thought before we transition into some questions. Talking about the DORA elite performers versus the low performers. So what does this actually mean to your organization? Well, the elite performers are deploying code 208 times more frequently than the low performers. If you think about multiple times per day versus once every 3 to 6 months, I think the math adds up there. And what's stopping these companies from moving at this rate? A lot of times it's not having peer review. A lot of times it's a heavyweight change management process. These are very closely related. What we found is that the larger the change and the more people that are responsible for reviewing it, the actual less likely people are going to be to look at the code. Whereas with peer review, when you're iterating rapidly, people come in, they look at 3 or 4 lines of code, they're working on the project, they're familiar, there's less errors, and you move much more rapidly. Moving on to the second one here, 106 times faster lead time. So just imagine your organization moving 106 times faster, actually getting from the commit to the production deployment. 2,604 times faster recovery from incidents. So that $10,000 to a few $100,000 per minute really adds up when you multiply it by about 2,500, and 7 times lower change failure rate. So essentially, if your developers have to run the pipeline 7 additional times and do some debugging 7 additional times, that's really going to add up over the course of a year. So this is important. These are the key DORA and DevOps metrics to moving your business towards an elite class. What we have found from our 15 years of experience in terms of how this actually impacts the bottom line is that you can see an ROI of 30 to 36% increase, right, through this bottleneck detection and helping your lower laggard teams moving to be the most optimal teams, like the most optimal teams in your organization. We see the development velocity increase, right? As soon as you have better tool chains in place, better processes, you're iterating more rapidly. The entire velocity increases by about 7 to 9%. We see a huge reduction in tech debt. So the larger the changes, the slower you're moving, the more tech debt that is accumulated. You have people working on large branches that then try to merge them on top of each other. Just another benefit of getting all this in place properly. And the last one here is that we have 99 to 100% of DevOps application issues. So you don't have to go in and put a trigger in every repo. You don't have to have your developers go and set up the linters. You know, essentially we just pull all that code, we evaluate it, we collect all the details, and we collect them in time series as well. So you can actually track the trends over time. Okay. So yeah, on that note, I think it's about time for questions, and I'll open up the floor.
Thank you, Richard. There's no questions in the chat, but if anyone wants to unmute themselves, please go ahead and unmute yourselves and ask the question.
Actually, I did put a question in the chat. Can you not see it?
Is that Ted?
Yeah.
Okay. Do you want to ask your question, Ted?
Okay. Yeah, thanks very much. I'm getting an echo, so I'll try to speak clearly. Hope you can hear me. Um, our concern, and this is great for productivity, and totally get it. Very efficient dev cycles there. But our concern as a bank is more about maturity, process maturity, and auditability, um, all those kind of quality
Sure.
sort of metrics, as opposed to purely productivity.
Gotcha. Gotcha. Yeah,
Is
that's a
that
great
something that this can help with? Essentially
Yeah.
put your banker hat on, right? And not your not your startup software company hat, right? We've got to be
Yeah.
super careful, and that's what we look for.
Sure, sure. So Stelligent works with a lot of financial institutes, right?
Mhm.
That's actually our bread and butter. We've worked with Citi, Northwestern Mutual, Great Western Financial, Capital One. I've personally, as a principal, I worked a lot with those organizations. So I do have a banker hat, but I wear the startup hat most of the time. This actually all started with application compliance. So it's sprawled out. But the first thing that we identify that our clients were is that there's no great tool for application compliance. Every one of our clients had some homegrown tool that was essentially going through their application code, looking for very specific flags that they wanted to identify were set up correctly. So we do have that functionality in place, and we understand how important that is. And then from a security perspective, the linters that we have in place, we've got CFN NAG, we've got config lint, we've got Halo lint for Docker. So we have a handful of different security linters that look at the DevOps files, the infrastructure as code, such as CloudFormation and Terraform, the Docker files, as well as the application code. So it's definitely top of mind.
Okay, yeah, thanks.
Hi, Richard. This is Hari from PWM team.
Hey.
Hey, Harry.
Yeah. Actually, all the tools are fine, but the thing is, currently we have a being a bank, we need to go to the everything for the change management for yes, single line change also. So, do we have any tools such that we can automate from the Jenkins to ServiceNow tickets, and it will upload the necessary fields and move it to the change management? And going to the approval transition process there. Any automation tool that you have worked on?
Yeah. So we do actually have a ServiceNow integrator as well. It doesn't make the main slide here, but we do have one, and it connects to Jenkins as well. Of course, being able to automate that process is critical. Mainly we're analytics tool though, so we can help you identify who's doing the best practices, who's moving the most quickly, right? And from there, you can take that information and use it accordingly.
Okay, thank you.
Sure.
We have one more question in the chat. It says, what repositories and version control tools are supported?
Yeah, great question. So we integrate to all the Gits, the GitHub, the GitLab, the Bitbucket, and that's essentially the scope of it. Any Git data.
Thank you. And there's one more. So does the Topograph tool offer APIs to be used with other applications? I think that's kind of similar to what Hari had asked before, but those lines.
Oh, gotcha. I thought he was asking if we connected to their API. Gotcha. My bad. So yeah, no, we've got the back end is Fast API. It's comes with Swagger UI out of the box. So there's a nice screen. I'll actually pop it open real quick. Okay. So yeah, this is what our backend looks like. Essentially, you can see all the different APIs that you want to hook up to, and it's got some documentation for the box for how to connect to them. And yeah, you can see the different data. Yeah, so essentially a developer could come in here and just kind of take a look at what data that he wants to pull and very quickly kind of do some samples and test runs and see what he gets back.
Fantastic. Thank you.
Yeah.
Yeah, so I think we are at time. It is 3:40, so we will take a quick break. Thank you very much, Richard, for that very insightful presentation. It's very appropriate for the moment that we are in at First Republic Bank with all the changes happening and a lot of people moving towards automation. So thank you very much. And um, we'll take a break now and we'll be back in 5 minutes at 3:45. It's 3:42, so 3:47 to get started with our next presentation. Thank you everyone for joining.
Thank you. Thanks so much for
Thank
listening.
you.
Have a good one.
Thanks a lot.
Bye.
Thank you.